Hi everyone. We are going to take some quick notes on graphing inequalities, and I hope as we go through these notes you are following along in your packet and you are going to add these to your notebook so you're ready to go. So I am going to make a key with you. All right, to start out with, when we are graphing inequalities, this is going to be graphing systems of inequalities. This is a lot like graphing just one inequality, except we're graphing both of them on the same graph. So a few things that I want you to pay attention to are the same things that we've been paying attention to when we've graphed just a simple inequality. But we'll make it very clear through this graphic organizer. So to start out, we have this system. We have 3x minus 4y is less than 4, and x plus 2y is less than or equal to 8. And we are going to graph this baby. As we do that, we need to follow some steps, and these are just sort of steps to keep you focused and make sure that you get all of the parts taken care of. First and foremost, we are going to write each inequality in slope intercept form. So if you remember, that's that y equals mx plus b format. However, in this case, we don't necessarily have an equal sign. We're going to have an inequality there, right? So each of these inequalities, we're going to have to make sure they're written in slope intercept form. Next, actually, let's just get these in slope intercept form. I'm going to draw my line down that inequality just so that way I can make sure I keep everything nice and focused between each side. So I'm going to subtract 3x on both sides. I then have negative 4y is less than negative 3x plus 4. And again, I'm writing in slope intercept form, so I'm going to have that x term up in front of my constant just to keep that focused. And then I'm going to divide by a negative 4. Ooh, I have to divide by a negative 4. I have to divide by a negative 4. I have to divide by a negative. When I divide by a negative, I need to flip my inequality. This is so important, and I've seen this be one of the biggest mistakes we keep making over and over and over. Make sure you flip your inequality sign because you've divided by a negative number. Remember, if we divide or multiply by a negative number, we have to flip our inequality. So I have negative 3 over negative 4 is positive 3/4 for my slope, x. 4 divided by negative 4 gets me a negative 1. So now I have one inequality figured out. I'm going to do the same thing over here with this other inequality. I'm going to subtract x from both sides. I have 2y is less than or equal to negative x plus 8. I'm then going to divide by 2 on every single term to keep the proportionality of that linear inequality. Get negative 1/2 x plus 4. That one I didn't have to divide by a negative number or multiply by a negative number. It was really straightforward. It's kind of awesome. Now, I have written each of my inequalities in slope-intercept form, so I've gotten step 1 taken care of. Now I'm going to graph one inequality primarily, I'm going to focus on the y-intercept first. And then I'm also going to graph one inequalities, or that same first inequalities, the slope. And as I do this, I'm going to just make dots at first because I need to decide whether or not I am going to be creating a dashed or solid line when I create my graph. And then I also need to decide after I've done that if I'm going to shade above or below, I can spell today, below the dashed or solid line. Now, let's remind ourselves what we do if we want to shade above or below. I'm going to change up this view so we can see this a little better. If I'm going to shade above, I want to see signs that look like, or inequality symbols that look like this. greater than or equal to. If I want to shade below, I want to see less than or equal to signs. If I have a dashed line, I want to see those less or greater than or less than symbols. And if it's a solid line, I want to see those equal to's underneath them. That's just a quick reminder for me. I highly suggest you have this on a note card if you ever take a test on this. It's super duper duper helpful to have all that information. So shade above or below, here's my awesome information for that. So if I look at this particular inequality here, y is greater than 3x minus 1, I can say this is going to be dashed or solid. There's no equal to, so it's going to be a dashed line. And because of that inequality symbol, it's also greater than, and greater than means that I'm going to be shading above. We can do this same thing. We can do this same thing with our other inequality. I'm going to try to scoot this up again. We can do the same thing with our other inequality. Our inequality is less than or equal to. Less than or equal to means that I am going to have a solid line because I have that equal to. So solid line. And I am going to be shading, in this case, I'm going to shade below because the y is less than everything else when it comes to that line. So I'm going to shade below. Okay, so I have all that information there so I can start to graph them when I'm ready. So shade above or below will be nice and awesome. And I'm doing all of this for just one of my inequalities. Then step number 6, do steps number 2 through 5 for the second inequality. I say do them separately, so go through all of the steps for one of them and then do all of the steps for graphing for the other one separately, one at a time, just so that way you don't potentially get slopes mixed up between different y-intercepts. So say you had this equation 3/4 x minus 1, you graphed the -1, but then you ended up using this slope by accident because you were sort of intermixing the two equations. Please graph one equation at a time, or one inequality at a time. Last but not least, our solution is the shaded overlap region. Sweet? Sweet. Now let's graph this. So I'm going to fold this baby up so I can look at it a little bit more with just the graph and these inequalities in mind. So here is my first inequality. I've already solved it for slope-intercept form. I now need to graph it. So my y-intercept is -1, so I'm going to identify that. I am then going to go up 3 units and then to the right 4 units with my rise over run. And as I do that, I'm going to just create little dots so that way I can make sure that I have the correct dashed or solid line and blah, blah, blah. So from this point, I'm going to go up 1, 2, 3, and then to the right 4. 1, 2, 3, 4. I'm going to make a dot. Same thing again. 1, 2, 3 up, 1, 2, 3, 4 over to the right. And I can even go down 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. And I can make my line. So now I'm going to do a dashed line because there was no equal to. So I'm just going to dash this baby in, and I'm going to make it obvious that it is not a solid line by making clear breaks in it. Yeah. And then I'm going to shade above. And I know I did not like actually shade in or anything. I didn't like hold my pen sideways, but that's okay. It's very clear what direction this particular inequality is shaded, and this is a valid way to shade for math. So now let's do this next one. We have this next inequality, y is less than or equal to -1/2 x plus 4. I'm going to identify my y-intercept of 4. Then I'm going to go down 1 to the right 2. Remember, I usually put this rise part, I'll either rise up or rise down or like fall down every single time. So I look at my rise as the positive or the negative. Doesn't matter if you look at the rise as positive or negative or the run as positive or negative. You just need to be consistent and don't change it partway through, or don't make them both be positive or both be negative, because if you have a negative inequality, you need to have a nice negative slope. This particular slope is going to be a solid line. So sorry, I do best when I can draw things side to side. So I drew my solid line and I'm going to be shading below. And now we can clearly see the overlap. So the overlap is the solution region. So any point that falls in this part of the graph, any line that falls in here, is going to be a solution to this system. That also includes any point that falls on this line, this pink line, up until the intersection point, but it does not include the actual intersection point. So if I look at this intersection point of 4, 2 is not a solution because of this inequality here not having an equal to. If we put these numbers into this inequality, we would get a false statement. It would essentially probably say something like, actually, if I think about this, 3/4 of 4 is 3 minus 2 equals 2. So it says 2 is greater than 2, which is a false statement because 2 is equal to 2. But because there's no equal to on there, this particular point is not a solution. As well, no other point on this dashed line here is a solution up until that intersection point. But every point here, as well as every point on the pink line up until the intersection, is a solution. All right, so I hope taking these notes and watching this happen in front of you was helpful. There are 2 more videos for this particular set of lessons. So please watch those, and then after that you can start working on the must-do practice problems and take the exit pass. Thank you so much for watching, and I will see you later.